So now that you know what a function is, in this video lesson, let me show you how to generally graph a function. Let's look at the basic method of how to graph a function. And so, let's say we're going to consider the function f of x equals 2x minus 1. So in class, you must have learned what this function means, what the function does to the x. The function name here we have is the function f. It takes the input argument x, and what the function does to the input here is it's going to multiply the inputs by 2 and subtract that by 1. And then that's going to generate the output. So if you're looking at, let's try to evaluate. Let's say if x equals 1, meaning you're going to try to substitute the value 1 for the function x. And here's notationally we have f of 1, and that would be equals to 2 times 1 minus 1. And here's we're going to have a 1. Now if we can do what happens if x equals 0, then the functions here, or notationally we can do f of 0 and equals 2 times 0 minus 1. And once again, that's what the function does to the inputs. The function multiply whatever the input is, multiply it by 2 and subtract 1 from it. And so the answer here is negative 1. Or if you're thinking about trying an input value to be negative 1, if x equals negative 1, notationally we have f of negative 1 equals 2 times negative 1 minus 1, and all that here would equals to negative 3. So now the point now is that how many of these, so we have tried about 3 different values for x. The point now is that we can always construct for ourselves a table. And in some classes, which to some instructor they call this the T table, because look at the shape, it looks like a T shape. But this table here, basically it contains 2 columns, and here the columns to the left hand side, I'm gonna basically make a list of all possible values for x, a list of the possible values we can think of for x. So here we have tried 1 for x, we have tried 0 for x, and we have tried negative 1 for x, and you can also try a few other values for x. So how about 2 and negative 2? Okay, and 3. And then we have computed earlier. Now when x equals 1, the function's value equals to 1. When x equals to 0, we already computed, and the function's value is negative 1. And when x equals negative 1, the function's value is equals to negative 3. And then you can also continue computing all these values here into the functions, evaluating those values into the functions. So what I can see now is when x equals 2, you can have 2 times, you can do 2 times 2 and minus 1, and that equals to positive 3. And when x equals negative 2, you have negative 2 times 2 is a negative 4, and minus 1 is a negative 5. And here I have 3 times 2 is 6, minus 1 is a positive 5. So now what's happening here is that those values that I put in on the right hand side here, each one of those is corresponding to a specific x value. So, or in other words, every single x value here gives a function's value for the function f. So now those values on the right hand side I'm putting on the table here, we call those, they are the real nature of those, they are the function's value at the specific x value. But in other case, we call those value the y value. More commonly, we call that the y value. And the basic idea for graphing now is that we're going to treat each of these, if you look into the table here, each row is indicating a pair. So here I have a pair 1, 1. That means the x value is 1, and the y value, which is the function's value, is 1. For the second row here, it's indicating on the table, it's indicating we have another pair 0, negative 1. The third row right here down on the table, we have negative 1, negative 3. And so these are the order pairs. minus 2, minus 5, and here I have 3 and 5. And so once again, each of these pairs indicating the x components is the x inputs of the functions, and the y value corresponding to the x value is the function's value that after we evaluate the functions. And now, and you can imagine, you can keep extending this table longer and longer, as many entries as you would like to. You can keep extending that table infinitely long. But now the point now is that these pairs right here, we put them on the x and y coordinates plane, and we call them a point. So each of these pairs make up a point, and all these points together, they make up some kind of trace, and that's what we call a graph. So now let me demonstrate the idea now. So let me turn over to my graph page. And what I'm having here, let's say here we have a graph space with all the grid here, and you can always draw for yourself the x-axis. You can draw for yourself the x-axis, and you draw for yourself the y-axis. Draw for yourself the y-axis. So keep in mind, the horizontal axis is always the x-axis, and the vertical axis is the y-axis. So the point now is that if you look back into the table that we have here, if you look back into the table, maybe it's a good idea to put it to the side here. So if you look back on the table, now the first pair that I have is a 1 for x and 1 for y. So from the origins, you're going to go over 1 for x and 1 for y. So here, it's indicating this point on the graphing space, and that has coordinates 1, 1 right there. 1, 1. If you're looking over to the next pair, we have 0, negative 1. So putting that on the graph, we have 0 on the x-axis. So this is my x-axis. 0 is right here, and negative 1 on the y-axis. So we have, it's going to be this point right here, 0, negative 1. And then the third point down, we're looking at, how about negative 1 and negative 3? So negative 1 on the x-axis, and negative 3, negative 1 on the x-axis, and negative 3 on the y-axis. And here at those two, when those two components meet, that's my point again. So now if you notice, if you observe the 3 points so far, it seems like they are lining up, and keep in mind, in between these points there are other points in between them, and which indicating those values that we didn't try. But once again, we can create a whole bunch of points like that. And here we have 2 and positive 3, so 2 on the x-axis and 3 on the y-axis. So here we have that point, and that's 2, 3. And now the next point, I have a negative 2, negative 5. So negative 2 and negative 5. So it's down here at this point right there. Negative 2, negative 5. And then the next point I have is 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And here's. Okay. So now if you're looking at these 6 points together, they seem to start forming some kind of trace, and that trace here is nicely a straight line. And so when you connect the dots here, when you connect the points, you're creating for yourself a graph. And this is the graph for the functions f of x equals 2x minus 1. And that's the idea of how you can basically graph a general function. So let's recap all the idea now. The x value, we're choosing the x value independently, and that's why sometimes you hear the terms, the x value here, we're calling them the independent variable. The y value is to be computed or evaluated based accordingly to the x value that you chose. So here, you plug in a 1 into the function, and you you can evaluate the y value to be 1. You plug 0 into the function, and you end up with negative 1 for y. You plug negative 1 into the function, and you end up with negative 3 for the function, for the y value, and so on. And is this the only table? No, the point here is that you can choose different values for x, but doesn't matter what values for x you choose, you might get a different table with different pairs of value. However, those points, they should line up in the same line as we have here. And so that's why I said in class earlier, every function has a graph.